So let's talk about file input and output in Python. With input and output, we have input and output from and to the screen, but we also have input and output related to files. The files can be text files, or they could be binary files. And binary files have this extra layer where the encoding relates to something a little more involved. So for example, there could be images or audio or video. A PDF is a binary file. Executables are binary files. And so these files aren't just raw characters, not just raw text. There's this extra layer. But Python gives us a way to work with either text files or with these binary files. Then we're also going to talk about a different kind of file called a JavaScript object notation file. So we'll go into more detail on that in a few minutes. So the standard way of dealing with files is a built-in function in Python called the open function. And so the open function has other parameters as well, but the three primary parameters are a path to the file, the mode that we're going to access the file that we're talking about, and then the encoding of the file. The default is none. Standard encoding is UTF-8. The mode in particular allows us to describe whether the file is for reading or writing or both, and there's some aspects of that. We'll go into some more details about the options that are available in the mode parameter. So the first mode we want to talk about is the default mode, which is the read mode, mode R. So if all we want to do is read a file, we can set the mode to be R if we want to specify that we're reading. If we leave that out, it will automatically be opened as a read option. If the file exists, then this mode will open the file as a read-only file. The file pointer is where in the file we begin, and so in the read mode, the file pointer is at the beginning of the file. So it's set in place to say, okay, start reading from here, start reading from the beginning of the file. If the file that we've specified does not already exist, and we try to open it in read mode, then we will get a file not found error. So the read mode can only be used to read existing files. The read and write mode, which is R+, so we set the mode to be R+, it opens the file for reading and writing if the file exists. Again, this is an add-on or an extension of the read mode, so the file has to exist first. Again, the file pointer is at the beginning of the file, and you get the same file not found error if the file does not exist. You try to open it for reading purposes, there will be an error if that file does not exist. If we want to write, then we have mode W. So mode W opens the file as a write-only file, prepares us to be able to write to that file, but it truncates the file. What that means is that anything that's in the file already is erased. It starts from the beginning, and the pointer is at the beginning of the file. We are ready to write to this new file. So we have to be really careful if we are wanting to see what's in a file already before we start changing things, because as soon as we open in mode W, then whatever was there is deleted. If we want to open with a read and write option from the W setting, we have mode W+. So the plus is saying let's interact in both directions with the particular file. It opens the file for reading and writing, but again, it truncates the file and the file pointer is at the beginning. Now, both mode W and mode W+ do create a new file if that file does not already exist. So if we give a path to a file and the file doesn't exist and we try to open it in read mode, we get an error. If we open it in W mode, then if that file doesn't already exist, it is created, and then we can start writing to that file. W+, the benefit is if you've written something partially to the file and then you want to, for some reason, analyze what's in the file, you can go back and read without closing it and reopening it for read purposes. But again, both of these, W and W+, will delete whatever is in the file at the beginning. There is another mode that is related to the write mode. It's called the X mode, and what this does is it creates a unique file for writing purposes. So it's a variation on mode W. And so what will happen in this case with mode X is if you say, let's open this file in mode X, it will create that file if it does not already exist at the path that you've stated. So if we say, hey, let's create a file with the write mode, and then later try to create another file with that same mode, or that same name, excuse me, in mode X, we'll get an error that says, no, that file already exists. But if that file name is not already in place, then the X mode will create the new file. So what this will prevent you from doing is accidentally overwriting a file. If you try to open in mode X, if that file name already exists, we get an error message. File exists. And so this will prevent the accidents of overwriting something that you didn't mean to overwrite. The X mode opens the file as write only, so there's nothing to truncate. It starts at the beginning of a blank file, and you can start writing. The file pointer is at the beginning of the file because that's really the only position in that specific file. There is then mode X+ that would allow reading after you've created the new file and start writing to that file, that you can then read in that particular file and then maybe keep writing later and so on. But mode X is specifically for the purpose of, it's really a variation of mode W, but it only opens the file if it can create a brand new file. There does not already exist a file with that name in that specific location. Now, both of the primary modes, the read mode and the write mode, reading is read only, write is overwriting whatever is there. It truncates and then starts fresh. Often we want to keep what we already have and add to it. And so to keep what we already have, we have mode A, which stands for append. So in mode A, we'll open the file for writing purposes. It does create a new file if the file does not already exist. But the file pointer, instead of pointing at the beginning of the file, is now pointing at the end of the file. And so if you do any writing, it does not delete what was already there. This does not truncate. It keeps everything that's there and starts writing at the end. There is a way in this scenario to change the location of the file pointer, and we'll see in a few minutes a method called the seek method, and you can change the location. But if you've opened an append mode, even if you change the location, that would be basically change the location and then say write something, it's still going to append to the end of the file. If you change the location with the write mode, the W mode, and start writing things, it will start writing from where you have set the position. But append mode is always going to write at the end. It's always going to append to whatever was already there. And of course, as an append mode, there's also an append and read mode, which is the mode A+. Opens the file for reading and writing. Still creates a new file if the file does not exist, the same as before. The file pointer is still at the end of the file, but you can move back to an earlier position and start reading from an earlier position if you choose. Again, all of the writing will still take place at the end of the file. There's a mode that we don't have to use, or an aspect of a mode that we don't have to use, but we can if we need to. The mode T represents that we are talking about text, and that's the default, so we don't have to specify that. But sometimes we will specify for clarity that the mode is text mode. So we could say mode equal RT. That would mean we're opening a text file for reading purposes, or mode A plus T would mean that we're opening a text file or as text for appending and reading purposes. And so the file contents are returned as a string, and if they're the bytes in the file are decoded using either a platform-dependent encoding or the specified encoding if the encoding is given. So if we say, hey, this is UTF-8, then those bytes are decoded according to that mapping. If we open a binary file, we can use mode B, and you append B to the mode for binary mode. So the data would be read and written as bytes objects. And this would be necessary if you were, say, editing a PDF or editing an image or a video. Then you would need to make sure that what gets written back in matches the structure of what came out. So bytes are there. You change something, you need to put bytes back in place. And so we would say, again, for reading purposes, you would open it in mode RB. Binary files take a little more care, a little more work to fully understand how they work and what kind of data you're able to put into place. So to implement the open function, we should use the strong recommendations from the Python community are to use the with construction. And so what this does is it's going to ensure that a file is closed properly. So we can use the close method, but sometimes depending on what has happened, the close method either doesn't work because there's an error that has happened earlier, so a file is not closed properly, or there is a writing that doesn't take place that we expect. And so we expected that we updated a file, but because it didn't close correctly, then the update doesn't actually take place. But the with construction will ensure that files close properly no matter what else happens, no matter what kind of errors happen, no matter what else is going on. And so, again, if you do not use this with construction that we'll describe in a minute, be sure that you do close the file using the close method, but it won't always behave the way we would hope. There are scenarios where that construction does not update the file the way we would hope. So to use the with construction, we say with, and then we'll open the file. In this case, we've called the file test underscore file. It's a text file. We've opened it in X+, which means that if there's already a file with this name, that it won't open, but if there is not a file with this name, then it will open it for writing and reading purposes because of the plus. The encoding we've specified to be UTF-8, and we're going to open this file, so we're going to call it F. That's just a name we've chosen to represent this particular file. You can use any valid Python name here. Sometimes you use names that are more descriptive of what's going on in tutorials and so on. It's often opened as F to just represent the file that we are looking at this point. Then you can write to that file, so f.write, write a string to that file. If we read that file, what's going to happen, we opened it in X+, so we are able to read, but what will happen is this reading will start at the end where the file pointer is located. It's located at the end of the text we just wrote. It started at the beginning, but then we wrote this text, so now the file pointer is at the end. So if we read, it's going to start reading at the end, and at this point, contents would be an empty string because, yeah, we read, but we didn't read what was there. If we want to go back and see what we've read, then we would have to do something different. But if we end the with construction and check to see whether the file is closed. So f.closed is an attribute that will describe or will tell us whether the file is actually closed. And at this point, if we type this exactly as it is, say in the idle shell or in a file, and we ran this, then f.closed will return true, because even though we didn't type f.close brackets, the construction ended because the tabbing ended, and so that automatically closes the file. But again, if we print the contents at this point, we have an empty string because that has started reading after the full stop at the end. So to make this work the way we want to, if we had included the line f.seek 0, what this will do is will put us back in at the beginning of the file, and then we will be able to start reading there. With that in place, then we would have this idea of wrote something, went back to the beginning, read that, saved it in contents, and print the contents. Now, if you did this without the f.seek, ran it and saw that contents was empty, but then just typed it all again and ran it again, then we get an error message that we tried to open a file or tried to create a file that already exists. And so you can only get away with this one time using X+, that putting new content into a new file, X+ only works the first time. The second time, if you wanted to run this again, you either have to delete the existing file or change the name of the file that you're trying to create. But in this version now, we wrote, here is some new data. We went back to the beginning. We read that. We saved it as contents. And we print the contents. And it would print, here is some new data. All right. Another approach that we could take is using the path library. It's in the standard library. So pathlib. It's an object-oriented file system path construction. And it's able to represent paths for different operating systems. So you don't have to worry about the operating system that either you are using or the operating system that if you write code for someone else, you don't have to worry about what system they're using. This will represent the path appropriately for that particular system, whichever one it's running on. Now, in this object-oriented approach, there are pure paths, which provide computational operations without the input-output aspect. And then there are concrete paths. And concrete paths inherit from the pure path idea and provide the input-output functionality. So pure paths are for use in things like virtual systems and so some other scenarios where we don't really want to write things to locations on the system that you're actually using. And so in that setting, the pure paths are more abstract and have their use, but for our purposes, we're going to deal with concrete paths. So we're going to provide the actual input-output capabilities. So the path class creates an instance of a concrete path for the platform on which the code is running. You run the same code on one kind of computer or a different kind. So if you run it on a Linux machine or an Apple machine or a Windows machine, then what is created, the code looks the same, but what happens behind the scenes is specific to that kind of computer. So this library is described in PEP 428 if you want to take a look at kind of the history and the details of what happened in the development of this particular library. All right, so to use this, we will import path. So this will be from the path library. So from pathlib, import path. And then when we want to create a particular path, we say, hey, I want to have a path to sample_file.txt. And so this is going to be in the same folder, the same directory as my code that I'm writing. And so path will create whatever's necessary behind the scenes for your particular computer. Again, P here is just a name. Sometimes you give it a meaningful name. Sometimes we give it a shorthand kind of name like P. There is an open method. The open method would be used with the with construction. It's very similar to the built-in open function. So you would say something like with p.open, open it for read purposes as f. And then we could do like read line, other kinds of things that you've seen before, possibly with how to read a file. But generally, what we do, instead of using the open method that's specific to the path library, we would do things like, here's the path to a file, and if we want to write text to that file, we would say p.writeText. Here is some text, and it will write that text to that file. So it opens the file, writes that text, so clears out what's there, writes that text, and then closes the file automatically. So write text, that method opens it, allows you to write, and then closes. If you want to read the file, then you would say at that path, read the text, open the file, read it, and here we're saving it off to contents, and then we could print the contents, and so we have contents now in memory rather than just existing in the file. Now, sometimes we will write a program that creates some data or that modifies some existing data or do something complicated. And then we want to be able to use that in future. We want to be able to save that for other use. And so the formatting of our data may be something that really matters. It may be something like a list or a dictionary. And so the brackets and the commas and in case of a dictionary, the curly brackets and the colons and all of these things are vital and they're important and they have meaning. If we just print those to a file, write those to a file, then it all just comes back in as a string. And so we want to be able to save the data and the formatting. And if we just have everything as a string, then when we try to open it again, it doesn't open as, say, a dictionary, it opens just as a string. And so we would have to process the string and make sure that we got all the pieces in the right place. And that can lead to lots of errors, especially if we are wanting to share data from a program we've written to a program someone else has written. So we need to be able to properly open something and make sure that it has the same meaning as before. And so this is where we get the use of something called JavaScript object notation. So JavaScript object notation, from the name you can tell, was originally intended to work with JavaScript, but it's a general use tool that's used in a lot of different settings. And so this type of file allows us to, say, create a complicated dictionary, let's say, and save it as this JSON file. By the way, this was created by Crockford and Morningstar in 2001. And they said when they created it that the name they came up with was JSON. And over the years, lots of people you will hear pronounce this as JSON because of like the object, the O sound. So you hear JSON. There's an official statement from the organization that's responsible for maintaining this. They say it's JSON. Douglas Crockford, who is the primary inventor, has said that he doesn't care. He just didn't know that anyone would say it anyway other than JSON. But he is perfectly happy with however you choose to pronounce this kind of file. But what it does is it allows us to have, say, a dictionary, save it to a file, and things that happen behind the scenes that we don't have to see, make sure that then when you open that file again, that it opens as a dictionary. And it is, the way it's designed is this then is able to be used in different languages. If you don't have that specific kind of data type in the new language, sometimes there are some issues. But if it's a data type that exists in multiple languages, or it can be interpreted in a meaningful way, then you can share data from not just one program to another, but one programming language to another. So when we want to write something with JSON, we will, again, we could do this without using the path library. You can open files, you're just using open. But we need to import JSON. And let's say that we have a dictionary that we've created. It has key 1 with a value of 17 and key 2 with a value of some list. And so what we will do is we will then dump that dictionary using JSON. The S in dump is dump the string. So we're going to dump this into a format that JSON will record this information. And then if we create a file path to some new file, in this case, rather than calling it a .txt, we typically call it a .json file. And then we could write those contents to that new file. So if you do this, if you follow these steps and put in this code and run this, you will see that in the location of your code, there's a new file called new file. It's a JSON file. If you open that with Notepad, you would see the dictionary listed in that file. And so this will open the file, write those contents in the appropriate way. As a text document, it looks like what you expect, but there's more going on that we don't see specifically in terms of that structure. Okay, so that is how you would write using JSON files. If you wanted to read now we have a different file, right? We're going to read this into a different file. We would still need to import our pieces and have our path to the file that we want to open. Now that's the one we just created. We're going to read those contents, and they come in as a string, and then we need to load that string. And so what JSON will do, I just said JSON, sorry about that. The load that and save it to Y. What this does is this converts the string back into the dictionary that we had before. So if we were then to print Y, we would see that it's a dictionary, or if we were to use Y just as a dictionary, then it will work the way we anticipate. So this allows us to save something and then open it at a later time, or either, again, you can open it in the same program. If you opened it in the same program further down, then you don't need to re-import. But the idea of being able to use something that we've calculated in one program in another program without having to recalculate. So there are some settings where there's a lot of data analysis, a lot of work that takes place. And then you want to save that. And then reopening it can be fairly quick, but to recalculate might take a really long time. And so if we can calculate, save things, and then come back to it later, then that will be a beneficial thing. And so these JSON files are good for being able to save certain kinds of data. Now, if we have a very specific, say, class that we have created, there are other tools or ways to use this to work in some settings, but there are other Python-specific tools that are available for that. We're not going to have to do any of that in the short term, but in the longer term kind of situations, this is the very preliminary aspects of how to save data for future use. All right, so as usual, feel free to ask questions in the comments by email or on Discord, and have a great day.